Hi, I am Khalil Ahmad, Assistant Professor of Physics, and the outline of my presentation is Kepler's laws of planetary motion. It is a very important and very interesting concept which was given by great German scientist, mathematician, astronomer Kepler. He is a key figure in the 17th century before Newton and Galileo, because Newton was born in 1643 but the Kepler is in 1571. On his observation, he announced the three important laws of planetary motion. The first law is the planet moves around the sun in an elliptic orbit with sun at the one of the foci of the orbit, which means all the planet revolves around the sun in an elliptic orbit with sun is at one of its foci, which means if you consider a circle it has the one center. If you consider ellipse it has the 2 points. You call it as one, you call it as focus. If it is two, you call it as foci. It is a plural. Now sun is at one of the foci of the orbit. And the second law states that the area swept out by radius vector drawn from center of sun to the center of the planet in equal areas in equal interval of time are equal, which means the aerial velocity is constant, which is nothing but, suppose if you draw a radius vector from center of sun to the center of the planet at a time some t1, the area swept by this planet must be equal to the area swept. Suppose here the journey of a planet from R to S, you call it as the time interval is t naught. Here also the t naught. The area swept you call it as A2, here the A1. These two areas are equal. That is the area swept in equal time interval is nothing but the area swept out by radius vector drawn from center of the sun to the center of the planet in equal areas in equal interval of time, which is nothing but aerial velocity, area swept by time is constant. And the Kepler third law of planetary motion states that the square of the period of revolution of a planet is directly proportional to cube of the semi-major of the axis. Period means one complete rotation. The square of the period of revolution of a planet around the sun is equal to cube of the semi-major axis. In a ellipse you consider this is the major axis and this is the minor axis. From center to its vertex you call it as semi-major, and from center in vertical position to its vertex you call it as semi-minor axis. You call it as the A and you call it as the B. Here in F1 you consider it as the foci, one of the foci. Okay. From this the time period of revolution, the square of the time period of revolution of a planet around the sun is equal to cube of the semi-major axis of the orbit, which you call it as the A. Therefore it becomes t square is directly proportional to a cube. Now let's derive the Kepler's laws of planetary motion from Newton's law of gravitation. We know that here the gravitational force of attraction is exerted by sun on the planet is always directed towards the center. Therefore, the force exerted between these two bodies is a central force. We know that when a particle moves in a central force field, its angular momentum and aerial velocity remains constant. So this is the Kepler's second law of planetary motion. Now let's move. When the angular momentum is constant, the planet moves in a fixed plane, just like in an elliptic orbit. Okay. We know that the magnitude of aerial velocity is given by half r square theta dot n cap. N cap is the unit vector which is equal to 1. Therefore it becomes half r square theta dot. We know that the aerial velocity is constant. You call it as the h. Half r square theta dot is equal to some constant h. You call it as equation 1. Now, by simplifying r square theta dot, which is equal to 2h. Now, you consider the radial acceleration of the planet is given by ar is equal to r double dot minus r theta dot square. Suppose you consider in a Cartesian coordinate system in the xy plane, radius vector drawn. Suppose here p is the particle or a point. Then from origin to the point, the radius vector, it is the radial acceleration, and which is perpendicular to the point or the planet, you call it as the transfer component. Here, because the planet move with sun is at one of the foci, therefore we consider the radial component. So therefore the radial component of acceleration is given by ar is equal to r double dot minus r theta dot square. Now that the gravitational force on the planet is given by F is equal to minus gmm divided by r square, which is nothing but every particle in the universe, every body in the universe attract every other body or particle with a force which is directly proportional to product of their masses and inversely proportional to square of the distance between them. Here, this is the gravitational constant, which is given by g is equal to 6.67 into 10 raised to minus 11 Newton meter square per kg square. Here m is the mass of the sun, m is the mass of the planet, and r is the distance between the two bodies. So the negative sign indicates that the force is always attractive, directed towards the center. It is a central force. The negative sign indicates that it is the attractive force. There is a force of attraction between sun and the planet. Now, from Newton's second law, you call it as F is equal to ma. You can substitute here. A means the radial acceleration, radial component of acceleration. Ma means F is equal to ma, mass of the planet, and here r double dot minus r theta dot square is the radial component of acceleration, which is equal to the force, gravitational force of attraction between the two bodies minus gmm divided by r square. You can simplify, you call it as the equation 2, that is you cancel m and here m get cancelled, therefore it becomes r double dot minus r theta dot square is equal to minus gm by r square. Now you call it as the equation 2. Now let assume that r is equal to 1 by u, you call it as equation 3. Now if you substitute the value of this or equation 3, from equation 3 the equation 1 becomes, that is theta dot by u square is equal to 2h. Equation 1 means r square theta dot is equal to 2h. If you write the value of r is equal to 1 by u, then it becomes theta dot by u square is equal to 2h. You call it as equation 4. Now differentiate equation 3 with respect to t. We get equation 3 means r is equal to 1 by u and r dot is equal to, just like the differentiate 1 by u is minus 1 by u square into du by dt, or you call it as u dot, which is equal to minus 1 by u square into du by dt, or you can easily simplify minus 1 by u square. You can write it as du by d theta into d theta by dt. Therefore, it becomes minus 1 by u square. Du by d theta is nothing but theta dot du by d theta. Now, from equation 4 is nothing but theta dot by u square is equal to 2h. From equation 4, we easily write r dot is equal to minus 2h into du by dt. Because this the value of theta dot becomes theta dot by u square is equal to 2h. Therefore, theta dot is equal to 2h u square. Therefore, it becomes u square get cancelled. Finally, you have r dot is equal to minus 2h into du by dt. R dot is equal to minus 2h into du by dt. Now, again, you can differentiate r dot, then it becomes r double dot is equal to d by dt of r dot, which is equal to, you can write in a, after simplifying it, d theta by dt into d by d theta of r. D theta by dt, you write it as theta dot d by d theta into r dot. Now, if you substitute the value of theta dot, then it becomes r double dot is equal to theta dot into 2h into d by d theta into du by d theta. Here just we are substituting the value of r dot. R dot is nothing but minus 1 by u square. Then it becomes minus 2h into theta dot d square u by d theta square. Now, from the equation 4, r double dot is equal to minus 2h into, equation 4 means theta divided by u square is equal to 2h. Therefore, theta dot becomes 2h u square. Just you can substitute here 2h u square. Theta dot is nothing but 2h u square into d square u by d theta square. Therefore, it becomes 2 2s are 4. Here minus sign is as it is. 4 h square u square d square u by d theta square. You call it as the equation 5. Now, substitute equation 3, 4 and 5 in equation 2. We get equation 2 just like r double dot minus r theta dot square, which is equal to minus gm by r square. That is the equation 2. You can substitute here, it becomes r double dot means minus 4h square u square d square u by d theta square minus r means 1 by u from equation 3. Theta dot square means 2h u square. You can square it, 2h u square whole square, which is equal to minus gm by r square is nothing but you write it as r is equal to 1 by u. Therefore, it becomes minus gm u square. Okay. Then you can simplify minus 4h square u square into d square u by d theta square minus you get cancelled. It becomes 4h square u cube, which is equal to minus gm u square. Now, dividing throughout by minus 4h square u square, we get d square u by d theta square plus u, which is equal to gm by 4h square. Now, or you can simply write, you take u to the right hand side, then it becomes, or gm by 4h square, the constant to the left hand side, it becomes d square u by d theta square plus u minus gm by 4h square, which is equal to 0. Now let this value u minus gm by 4h square is equal to u dash. Since this term gm by 4h square, h is the aerial velocity constant, m is the mass of the sun is also constant, g is the gravitational constant, the whole term is a constant. Then we have d square u by d theta square, which is equal to d square u dash by d theta square. Because this term is the constant, therefore u is equal to u dash. Then you can write d square u by d theta square is equal to d square u dash by d theta square. Therefore, it's become, this equation become d square u dash by d theta square plus u dash square. Now the solution of this equation mathematically is given by u dash is equal to a cos theta plus b sin theta. Now let the initial condition be chosen in such a way that b is equal to 0. The whole term becomes 0. Then the remaining solution becomes u dash is equal to a cos theta. Now you can substitute it. Then it becomes u minus gm by 4h square is equal to a cos theta. Or you can write 1 by r, u means 1 by r, minus gm by 4h square is equal to a cos theta. Or multiply throughout by 4h square by gm. Then we get multiplying 4h square by gm to this factor, multiply 4h square by gm to a cos theta. Then after simplifying, you can multiply just 4h square by gm by r, this get cancelled, gm 4h square 4 square, it's become 1. You can take to the right hand side, it became 1 plus 4h square gm by a cos theta into a cos theta. Therefore this is the form of L by R is equal to 1 plus e cos theta. This is the form of, which is nothing but the equation of a conic section in a plane polar coordinates with origin at one focus. Therefore, the path of a planet is a conic section with the sun at one focus. Now let us consider L is the semi-lattice rectum of the ellipse. What the semi-lattice rectum means? It is a line segment that is perpendicular to the major axis passing through the focus and is given by this constant. The eccentricity, it is also a very important concept in the ellipse, which is given by E is equal to C by A, which means it is a measure of how nearly the circular the ellipse. E is equal to C by A means distance from the center to focus divided by distance from center to vertex or center to semi-major axis. Suppose this value E is less than 1, you call it as the ellipse. Suppose this value is equal to 1, you call it as parabola. Greater than 1, hyperbola. Is equal to 0, E is equal to 0, you call it as the circle. So it is nothing but E, eccentricity of an ellipse, is a measure of how nearly circular the ellipse. That's it. Okay. From this, it has been found that E is less than 1 for all the planets. Therefore, the conic section is an ellipse. The Kepler first law states that all the planets revolving around the sun in an elliptic orbit. Therefore, E is less than 1 for all the planets. Therefore, the conic section is an ellipse. This is a proof of first law. we know that the semi-major axis of the ellipse is given by L divided by 1 minus E square. We know that the semi-minor axis of the ellipse is given by B is equal to A into root of 1 minus E square, which is equal to L by root of 1 minus E square if you substitute the value of A, major axis. Now the area of ellipse, the total area of the ellipse is given by S is equal to pi AB. You can substitute the value of A and B, that is pi into 1 by L by 1 minus E square into L by root of 1 minus E square. Then it becomes pi into L square divided by 1 minus E square whole to the power of 3 by 2. Now the aerial velocity of a planet is h, that is the constant. We can define the period of a planet is nothing but the total area, one complete rotation, the area of the ellipse divided by aerial velocity. We know that the area of the ellipse is given by pi AB and the period t is given by, you can substitute the value pi into L square, that is the area of ellipse, divided by h is the aerial velocity into 1 minus E square whole raised to 3 by 2. Now squaring the whole terms, t square is equal to, this becomes pi square L raised to 4, it becomes L raised to 4. Suppose you can square it, then here become h square, and this square means they get cancelled. Square root get cancelled, 1 minus E square becomes cube. After simplifying you get pi square is pi square, and then you can substitute here, that is this become a cube. Here L raised to 4, if you square it, it becomes pi square L raised to 4. You take 1 L as it is and become a cube divided by this whole term cube, 1 minus E square cube. Then it becomes a cube, because a is equal to L divided by 1 minus E square. So therefore this term becomes pi square a cube L divided by h square. Okay. So therefore the term, this term you call it as the L, but we have L is equal to 4h square by gm. Therefore L by h square, you can say this L divided by h square becomes 4 by gm. Now you can substitute this value, t square is equal to L by h square. L by h square, you can substitute the value 4 pi square by gm into a cube, which is nothing but the whole term 4 pi square by gm is a constant. Therefore t square is proportional to a cube. This is nothing but the Kepler's third law of planetary motion. Thank you. Thank you very much.